Halo, kita lanjutkan persiapan Matematika ASEAN Scholarship untuk Entry Level Secondary 3. Kali ini akan dibahas contoh soal Secondary 2 Singapura dari soal ujian akhir tahun 2018 Anglo-Chinese School Barker Road. Soal-soal ujian ini diambil dari website studykaki.com. Perlu diingatkan kembali bahwa menurut aturan seleksi matematika ASEAN Scholarship tidak diperbolehkan menggunakan kalkulator. Namun dalam pembahasan ini ada satu contoh soal yang menggunakan kalkulator. Selamat menyaksikan.
Hello everyone, welcome back. Today we'll be looking at secondary 2's exam papers, and we're going to look at 5 questions as per usual. So let's start right away. So for question 1, we have Tom, Sam, and Matt who are competing on a circle track, and each of them have their own respective times, 12, 15, 18 minutes. And if they start together and they run the same direction, maintaining the same lap times, how many more laps will Tom have completed than Matt when all 3 of them next meet on the starting line together? So for the first step of this question is to actually identify that this is a lowest common multiple question. So we first need to find what the lowest common multiple of 12, 15, and 18 are. And how we do that is we use um, the prime factorization of each of them. So 12 will be 12 squared times 3, 15 will be 3 times 5, and 18 will be 2 times 3 squared. So we take the highest powers of each of them, 2 squared times 3 squared times 5. So the lowest common multiple is 180 from 4 times 9 times 5. Okay, so now that we have 180 minutes, this means that the next time they actually meet on the starting line together will be 180 minutes after they started. So this will happen 180 minutes after they started, and the question is asking how many more laps will Tom have compared to Matt. So Matt's time is 18 minutes, meaning that Matt would actually complete 180 over 18 minutes, which is 10 laps, because each lap takes 18 minutes and the total time is 180 minutes. So he would have completed 10 laps by the time they meet together, and Tom would have completed 180 over 12, which is 15 laps. So Tom would have completed 5 more laps. For the next question, we'll be taking a look at exponentiation and how we can manipulate certain exponents and bases. So for these kinds of questions, we want to simplify the base as much as possible. So for 64, we notice that this is the same as 2 to the power of 6. So this will be equivalent to the power of 6 over x power 18 to the power of negative 1/3. And notice that there's actually multiple ways to do this question, but one fast way to do it is you notice that this can be simplified into 2 squared divided by x to the power 6 to the power of 3. And then you power it again with negative 1/3. So this is one way to do the question, and you'll eventually be able to simplify it into 2 squared to the power of x power 6 to the power of minus 1, because these two can be multiplied together. And this will be just simple flipping. So negative 1 is basically flipping these two together. So this, if you simplify this again, it becomes x to the power of 6 to the power of 4. Another way to this question is to simply just multiply the exponents respectively to each of them, and you'll get the same answer. For the second question, we'll take a look at part B. So in this question, we have this divide right here, and in these kinds of questions, we want to turn this into a multiply. So that's usually the first step. So let's do that right away. So 3a to the power of 4 divided by 10ab squared multiplied by 15b to the power of minus 1, 27a minus 2. So when we convert this divide into a multiply, we want to flip these two respectively. So this becomes 3a to the power of 4 over 10ab squared. And in this question, we have negative power. So what I'm going to do next is I'm going to convert them into positive powers, because I think most people would be uncomfortable dealing with negative powers. Sometimes they make small mistakes, so I'm only going to use positive powers in this question. And to convert these into positive powers, we just need to move them to the opposite side. So this becomes 10ab squared, and this is 15 a squared over 27b. So next is we want to simplify this, and we can cancel out some things here. This becomes cancelled out, and this becomes 9. 10 can be cancelled with 15 to become 2 and 3. And 3 and 9 can be cancelled to become 3. So we're left with a to the power 4 over 6 over 6b. Oh, sorry, this should be a to the power 5. So 4 here and 1 over here. To the power of a to the power 5 divided by 6b. Now for the third part, we have subtraction happening here. And we can't do this directly because these two have different denominators. So the first step is we want to equalize the denominators. And to do that, we want to first factorize this into x minus 2, x plus 2. So this is a very common quadratic form. A squared minus b squared is a minus b plus a minus b times a plus b. So minus 2 over 2 minus x. And this is actually the same as just plus x minus 2. So because 2 minus x is equals to negative x minus 2. So I just turn this into a negative and turn the sign into a positive. And this will actually be equals to x over x minus 2, x plus 2, plus 2, x plus 2. And this is now just basic simplification. 3x plus 4 over x squared minus 4. For the third question, it's quite interesting. We have a sequence called t here, where t1 is 1 and t2 is 1 plus 2, t3 is 1 plus 2 plus 3, and so on. So the first part of the question is quite simple. We just need to find what t6 and t7 are. And you can notice that from the pattern, we can see here that it for tn is equals to something plus n. So it'll just be n minus 1 plus n minus 2. So it's basically just the sum of all numbers from 1 to n. So to get t6 is actually just 1 plus 2 plus 2 plus 3 plus 4 plus 5 plus 6. And we actually already know what 1 plus 2 plus 3 plus 5 plus 4 plus 5 is, because that's t5. So t6 is actually just t5 plus 6. And the same goes for t7. t7 is actually just t6 plus 7. So we know that t5 is 15 here. So the next number is 15 plus 6, which is 21. So this is 21, and t7 is 28. Now for part B, it's a bit more difficult. What it's asking is why exactly is 200 not in sequence? And in order to be in the sequence, it basically means that tn must be equals to that number for some n. So now what this question is asking is tn equals 200 is actually not possible. So there's no such n for this is possible. And now we're going to understand why that's the case. So let's say 200 is equals to half n plus 1. That means that 400 is equals to n times n plus 1. And you actually notice that there's no possible n for this to be true. So let's first try, let's say n is equals to 19. If n is equals to 19, then n times n plus 1 would actually be equals to 380. So so n times n plus 1 would be 380. But if we try to increase n by 1, so basically increase this number, you'll see that it actually overshoots, because if n is equals to 20, n times n plus 1 would be 20 times 21. And 20 times 21 is actually 420, which is too high. And no matter what we do to this n, let's say we increase it even further, this number would keep on going higher. And if we keep on lowering this number, then this number would also go lower and lower. So we'll never actually reach 400. So if we try to find what T19 is, it's actually just this number divided by 2, it's 190. And T20 is this number divided by 2 is 210. So you notice that 200 is actually in between these two, but there's no number such that Tn will ever be 200. So let's use the formula to find T100. And this is a relatively easy question. T100 is just half times 100 times 101. And this would be equal to 5050. Use your answer to part C to find 5 plus 10 plus 15 plus 500. Okay, so now this one requires a bit of logical thinking. So if we know that T100 is 5050, and we also know that T100 is actually just equals to 1 plus 2 plus 3 plus 4 plus so on until plus 100. And what the question wants is 5 plus 10 plus 15 plus 500. So multiples of 5 basically. I noted that the ending is actually 500, which is 5 times 100. So you'll notice that there's actually 100 numbers in here. And that means we can use this sequence right here to find what that is. And how to do this is actually just 5 times T100, which is 5 plus 10 plus 15, so on, plus 500, which is exactly what we want here. So 5 times T100 is just 25,250. And hence, find the sum of all the whole numbers from 1 to 500, which are not multiples of 5. So what we want to do is want to exclude all of these numbers right here. So we want to first find what T500 is. So T500 is half times 500 times 501, which is just 125,000. Okay, this is not, I'll just remove this first to create some space. So the answer should be 125,250. And now we need to subtract basically all of these numbers from the total. So the final answer should be 125,250 minus the answer we got in part D, which is 25,250. And that is just 100,000. So for question 4, we'll have factorization and simplification of algebraic expressions. So let's start with the first one. The first step I want to do is I want to remove all of these denominators. So I'm going to multiply both sides by 6 to make it become 4x minus 3 plus 2x plus 2 equals to 15. And after that, we'll have 4x minus 3 plus 2x plus 4 equals to 15. I'm going to be left with 6x equals to 14. And x equals to 7 over 3. Yeah, so from here, I simplified each parts independently. So for the terms that have x, I added them together independently from the constants. So minus 3 plus 4 becomes 1, and then the 1 I moved into the right side so that it becomes 15 minus 1, which is 14. So for part B, we need to factorize 2x squared minus 32y squared. So I'm just going to do that part over here. And notice the first thing is that you can actually factor out the 2. So this becomes 2x squared minus 16y squared. And next observation, as you notice that 16y squared is actually just 4y squared. So this becomes 2x minus 4y, x plus 4y, because this is in the form of a squared minus b squared, which simplifies to a minus b times a plus b. And using this part right here, we can solve part 2, which is simplifying this fraction right here. So firstly, the upper part, we can simplify, we can factor out the 2x. So in here, 8x contains 2x as a factor, and 2x squared also contains 2x as a factor. So we can factor out 2x, and this will become 4 plus x. And for the denominator, we already factored it out in the previous question. So we just put whatever we wrote in the previous question, x minus 4y and x, oh, sorry, this should have a y here, x plus 4y. And now we just need to simplify accordingly. And we already can see that this can be simplified, this can be cancelled out. So the final answer is x over x minus 4y. And the last question, which is arguably the hardest, is a very common question, which is swapping the variables that is the subject of the formula. So the subject of the formula means the one on the left side, which is alone, that does not have any coefficient, only itself. So firstly, I want to remove the square root right here. And to do that, I need to square both sides. So y squared is equals to 4x over px minus 1. And next, I want to basically make sure that this px minus 1 is no longer the denominator, because that would make it very hard to deal with. So I'm going to multiply both sides by px minus 1. So we'll be left with y squared px minus 1 is equals to 4x. And I'm just going to expand everything out. Py squared x minus y squared is equals to 4x. And I'm going to move the x's into the left side and the y to the right side. So py squared minus 4x is equals to y squared. So notice that both of these has a common factor of x, so I can basically combine the coefficients together. And by doing this, I can divide both sides by py squared minus 4. So the final answer is x equals to y squared over py squared minus 4. So for question 5, we will be taking a look at angles and trigonometry. So firstly, I'm going to explain what bearing means in this question. So for example, we have bearing of r from P is 40 degrees. What it means is that if we draw a line towards the north from P, and we draw a line in between P and R, if we go clockwise from that north line, what is the angle until it reaches the line? So in this case, this is 40 degrees. And the bearing of Q from P is 336 degrees. Same idea. North line in P, all the way until it touches the line in between P and Q. So this is 336 degrees. And we now know that this is 24 degrees because 360 degrees is a full rotation. So this is 360 minus 336. And now what we want to find is the bearing of P from Q. And to do that, we draw a north line here, and yep, there we go. So what angle is this? And this is quite simple, actually, because we can actually extend this line here. And if you notice, these two lines are actually parallel. Both of them point to the north, which means that this angle right here is the same as this angle, interior angles. So this is 24 degrees. So the bearing is just 180 minus 24, which is 156 degrees. And now we want to find the distance QR. And to do this, we need to use the cosine rule. So QR squared is equals to 72 squared plus 37 squared. Oops, 37 squared minus 2 times 72, 37, and multiplied by cosine of 64 degrees. And eventually, if we calculate this, you'll get QR is equals to 64.9 rounded to 3SF. Okay, so now we want to find the distance RS. And to do this, we can use the sine rule. So firstly, we want to find the angle right here, which is actually calculated from 90 minus 24 degrees, because this is actually a right angle triangle. So this will be equals to 66 degrees, 66. And now we can use the sine rule that 37 over sine 66 is equals to RS over sine 64, which is the one right here. So RS is equals to sine 64 over sine 66 multiplied by 37. So for part B, we want to find the greatest angle of elevation of the top of the helicopter from the boat. So this question is a bit hard to understand, but basically we'll have a helicopter right here and a boat somewhere along PR. And this helicopter is actually above the island S by 5 kilometers. So if we want to visualize this vertically, we can write it down as like this. We have 5 kilometers and we have the boat here. Boat, this is the helicopter, and this is somewhere PR. And yeah, the angle of elevation is like this. The angle of elevation is this angle right here. So um, how do we find the greatest possible angle of elevation is we first need to realize that in order to find that greatest angle of elevation, we want this line right here to be as short as possible. And the reason is because we know that the height right here is constant. And to increase this angle, we want this to be as small as possible. And you'll realize this if you, let's say, just draw a bit. You'll realize that the uh, the bigger the hypotenuse, the smaller the angle of elevation. So how do we find the shortest possible HP? Well, the answer is actually, in order for the HP to be the shortest, this line right here, OB, must be perpendicular to PR. So firstly, I'm just going to erase some stuff over here. We want to find the line such that this is perpendicular. Okay, and how do we do this exactly? Is we can just find this angle first. So firstly, I'm going to find that angle by firstly noting down that this is 40 degrees. And if this is perpendicular, then this would definitely be 50 degrees. And notice earlier that we said that this is also perpendicular. And we also know the value of this RS. So we're going to use the more accurate version of this. So don't use 36.4 degrees. We're going to use the more accurate version, which is in 5 significant figures. So that should be 36.403, 403. And this is 5SF. And basically 36.4 rounded to 3SF. The height, so I'm just going to call it D, is equals to 36.403 times sine 50. And that should give us 27.886. And this is 5 significant figures. Okay, so now that we know the distance is 27.886, we can find the angle here using an inverse tangent. So tangent, no, the angle is equals to tangent inverse of 5 over 27 point. I'm just going to erase this because it's blocking the way. 5 over 27.886. And this will give us 10.2 rounded to 1 dp, decimal place.